Remember when we started chapter 8, remember we had that little activity end of last week, right? On dealing with the Hershey Kisses. And what we were doing is we were looking to try to estimate a proportion, right? Estimate a proportion of the times that it would land on its base rather than on its side, okay? And that's the idea of this whole chapter. This whole chapter, we're estimating either a proportion or estimating a mean, and then we're building a confidence interval around it, okay? What are reasonable values for that true parameter, that true value, okay? So one of the things we talked about was we can manipulate the size of these intervals. There's a couple of things that go into the construction of these intervals that we can control how big or small, or you could say wide or narrow, that interval becomes. So let's say a pharmaceutical company makes confidence intervals from a sample of individuals to determine the proportion of people they can expect pain relief from its new medication. It reports a 95% confidence interval to be from 25.6% up to 44.2%. For each of the following, indicate if the resulting interval will be wider, the same, or narrower than the given interval. Okay, so we have this interval here. Okay, we're told they made a 95% confidence interval. Okay, and now let's turn things around. Now let's say Instead, they made a 98% confidence interval. So changing that confidence level has an impact on the size of the interval. Does anybody remember, if I need more confidence, is that going to make it wider or narrower? Wider, yeah. Because it doesn't kind of make sense. If I want to be more confident I actually have the value, if I captured more numbers, wouldn't that do the trick? Right? The more numbers I catch, the more likely it is that I've actually gotten that true value. So if I up my confidence level, it is going to result in a wider interval, okay? A larger confidence interval. What if I used a sample size that was 4 times as large? Well, in chapter 7, we talked about the consequences of upping sample size. What does upping sample size do? Less variability. Well, if I have less variability, wouldn't that also kind of inherently go hand in hand with having a smaller interval? Less variability means my interval can be smaller, right? It's more compact towards that value that I was searching for. So if I up sample size, you get a narrower interval. Now, here, I can even be more specific if I choose to be, right? So remember, if I have something 4 times as big, we know the interval is getting smaller, right? We understand that much. How much smaller? Is it getting 4 times as small? No. How many times smaller is it? 2. Why 2? Where did that come from? Square root. Remember, in the formula for standard deviation, it doesn't matter which one you're using, mean or proportion, isn't that inside of a square root? So square root of 4 is 2. So it's going to be 2 times narrower, okay? Or you could phrase that as half as wide, right? Either one would be an equivalent statement to make. So these are the 2 biggest ones that typically pop on the AP exam. There is a more subtle thing that can happen, right? This is something we touched on last week, but I honestly don't remember you to remember as much as the other 2 because it was a much more minute detail. But changing the proportion itself, because in building standard deviation, doesn't this proportion isn't that involved in creating that standard deviation? So if this is different, inherently that would have subtle consequences to the size of the interval as well. So let's talk first of all, they're talking about changing the sample proportion to 45%. What if the sample had actually been 45 instead of whatever it was? Well, if I need to make that comparison, don't I first need to know what the sample actually was from the get-go? Right? If I have the interval sitting right here, what can I do? Where would my sample proportion be in that interval? Exactly. Oh. What? In the middle, yeah. Isn't that where we start? We start with our sample proportion and then we build this margin of error around it. So if I need to go backwards, if I need to figure out what that sample proportion was, wouldn't that literally just be the middle of my interval, right? Another word for that we talked about on Thursday, I think, yes, Thursday, was point estimate. Okay, the point estimate, the sample proportion would be the middle of this interval. How can I find the middle of this interval? Mathematically, what did you define its middle? Yeah, the average, right? I could average those two numbers. That gives me what the middle is. So 0.256 plus 0.442, I divide that by 2. So my original sample had about a 35%, right? 35% of people saw pain relief. And now they're saying, well, what if? What if it was 45% instead? Okay. Well, does anybody remember? I kind of related this to calculus in a sense that with dealing with these proportions, there is a worst case scenario, okay? There's a proportion that actually will create the biggest standard deviation. What proportion creates the biggest standard deviation? Does anybody remember? I don't blame if you don't. I know this has been like 6 days off now. No? All right, 50-50. If the sample proportion, if you had 50% here, 50% actually would, in the end, create the biggest standard deviation possible, okay? So remember we talked about that sample. If that sample, the closer it is to 50%, the slightly bigger and bigger and bigger the standard deviation will get. So notice it was 35%. So if I use 45%, isn't this closer to that 50? Which is our worst case scenario, right? The biggest deviation that we're going to see. Well, if this is having a bigger deviation, is that going to create a bigger or smaller interval? If this is has more variability. Bigger. This is going to be wider. The closer this is to 50, again, the more variability you're going to see, the bigger standard deviation you're seeing. So it would actually result in a bigger interval. So that was one of the things that we had to wrap our minds around, right? How can we control the size of our interval? Now, the biggest thing was talking about this 4-step process, right? If I ask you to actually make an interval, which again is so frequent on the AP exam, okay? Almost every year, this pops up on the AP exam, that they want you to construct a confidence interval, okay? Nice thing is, once you know how to do it, it is literally the same every single time. So it's actually a really nice process because this is a process I've also said we use in chapters 9, in chapter 10, in chapter 11. So when you get good at it now, you'll be set for literally the rest of the semester. Okay, so in this example, in January 2010, a Gallup poll asked a random sample of adults, in general, are you satisfied or dissatisfied with the way things are going in the United States at this time? In all, 256 said that they were satisfied, and the remaining 769 said that they were not. Construct and interpret a 90% confidence interval for the proportion of adults who are satisfied with how things are going. So again, this is the prompt. If they tell you construct and interpret an interval, that's a prompt that tells you, all right, we're going to go through this whole 4-step process, a whole shebang. All right. So the first start part, the state step, is the easiest, right? Because don't you just have to give this thing a name? You just have to say what you're doing. And again, in this first section, that was relatively boring because it's always going to take the same name because you only know one process right now. Okay. You're taking one sample and you're building a Z interval for a proportion. Again, that will get more interesting as I add to your repertoire. Again, you're going to know 13 of these processes by the end of the semester. The plan step. So the plan step, this is where we have to check our conditions. We need to make sure we can actually make this interval, okay? There's 3 conditions you need to check to make sure that this interval is actually going to be an accurate representation of the population parameter. Does anybody remember what the first one was? It was the easiest of the 3? Random. And why do I say that's so easy? What do you need to do for random? Don't you just really have to state that they stated it? Right? Did they reference randomness somehow? Yeah, ask a random sample. Boom. Gallup asked a random sample. So again, it really is just telling them that they told you that it was random. So easiest of the 3. Next one. What was the next thing we had to check? Random, then what? Um, that's usually the third one that I do. There's one. I mean, the order doesn't matter, but that's just the third one I have. Do you remember what that middle one was? Normal. All right. We need to check that this is going to be approximately normal distribution. What did that look like? How do we check for normality? Uh, no. Nope. That's for means. Successes and failures, right? What needs to be true about the successes and failures? Yeah. So here, wouldn't these be the successes and these be the failures, right? These are the people that said yes, they were satisfied. These are the people that said no, they're not. So there we go. So remember, you have to give me the numbers and you have to relate it that they're both over 10. Remember, if you don't say that they're both over 10, they call that stating the condition, not checking the condition. So you do explicitly have to say that both of those numbers are at least 10. And then, Cindy, you were telling me about the last one. What's that third condition that we check? Yes, that we sampled less than 10% of the population. Well, here, is it reasonable to think they're talking about sampling adults? Is our sample reasonably less than 10% of all adults in the US? Yes. All right. Then, after you establish all of this, okay, then we dive into the math, right? Actually making this confidence interval. Well, to make the confidence interval, remember, we start with our sample proportion, right? And we found 256 people that said yes. Out of how many? How many people did we sample? And how did you get that number? You added them, yeah. This is our successes, this is our failures. So wouldn't we actually have to add those together to get the total number of people? So here, I'm seeing 1,025 people in the sample, okay? Because I had to add up the yeses and the nos. So 256 divided by 1,025, that's giving me 0.25, all right? So around 25%. Plus minus, now we take that sample, and now we start constructing that margin of error around it, okay? Remember, the first piece of that margin of error, didn't that first piece of the margin of error come from this packet that I gave you, right? So can everybody take this back out for me, this new formula packet that I gave you? Because remember, the new one I gave you has an important component that you need to constructing these. And you need one, don't you? There you go. All right, so recall, this, I believe, was this a 90% confidence interval? Yeah. So remember, if you're flipping around, eventually you'll come to a table that talks about confidence levels, right? Table B, I think, yes. So find the table that references confidence level. And remember, if we're dealing with a 90% confidence level, if I just look up from that, do you see that 1.645? Remember, that's the number that we need, okay? So that 1.645, and then we need to construct that standard deviation. Well, again, this formula packet can help you if you need help with that. Remember this page I showed you for the Chapter 7 test? So if you need help creating your standard deviation, doesn't this remind you how to make it if you need that help, right? It tells you take your sample proportion, the opposite of your sample proportion, over your sample size. Is it slowly coming back? Is everybody remembering this from last week? I know it's been a while. Jake, even you, yeah. All right, now the cool thing is, remember, I don't actually need you to do this math, right? Wasn't there a calculator command that I let you use to avoid having to type this into the calculator, right? So let me refresh your memory on that calculator command. If you go into stat, over to test. Now remember, TI, I don't know why they did this. They have so many useless tests in here that you're not going to need, okay? So don't stress out. In no way, shape, or form am I going to make you know every single one of these. Most of them are useless, to be honest. But what we're looking for is we took one sample and we're trying to create a Z interval for a proportion, right? So as you're scrolling down, do you remember getting to letter A and that this perfectly fit the description that we wrote that we were looking for? One sample, Z interval, and we're doing this for a proportion. Okay, so in this section, remember, we're dealing exclusively with A. As we're going, one of the skills we're also going to have to acquire is telling the difference between which one we're going to end up wanting once you have more that you know. When you go into the program, you need a couple things. You need your number of successes, which in this case was 256. You need your sample size. What was that again? 1025. And you need your confidence level, which in this case, oh, no, was 90%. Run the program. And we're getting about 0.228 up to 0.272. Yeah. Yes, it is. Yep. So this is doing the math for you, so you don't have to plug it in the calculator and do it, because that would be very clunky. All right. Does everybody have this jotted down? 228 to 272. And finally, remember, in the end, you have to interpret your interval. So the conclude step is where you interpret it. The nice thing is, remember, the interpreting piece is always structured the same way. We are, however, percent confident the interval from whatever we found captures the, and then remember, my best advice for you is, didn't I just copy paste this straight into my answer to get my good context? So remember, that is my best piece of advice for you. When you're setting up your conclusion, okay, where however percent confident the interval from blank to blank captures the copy paste, okay? Literally take all of their phrasing from your prompt, and that becomes the context of your conclusion to make sure that you're phrasing everything well. So again, any questions? Is this coming back? Does it seem familiar? Again, I know it's been a while. Wait, I did? Oh. All right. Now, the other thing. Shh. So remember, we also talked about this 90 seems just very theoretical, right? Very abstract. So another thing they can ask you, and this is a very, very common multiple choice style question, is interpreting, what does that level mean? What is this 90% that we're using in this context. Well, remember what that 90% means is if we did this many, many times, we repeated the sampling procedure over and over and over again and made interval upon interval upon interval, 90% of them should contain that population proportion. 90% of them should contain that proportion that we were searching for. So again, heads up, this usually is not an FRQ. This is actually usually a multiple choice question that I see very commonly. That's how they end up giving this skill to you. Hey, did you guys see me at the game last night? I was there watching you. Oh. I don't want to ask. Help me. Welcome back to second semester, everybody. Actually, you're not wrong. That's true. All right, so up to this point, even though I know we had a big break in here, but all of this has been review so far, right? This is literally the stuff I went over last Thursday with you. This next little section is the new material for today, okay? I talked to you about a lot of review with the new in this section, but something you can do is let's say I'm trying to set up a sample, okay? And let's say I have in mind how much error I'm willing to accept in my sample, okay? Now, didn't we say, doesn't the sample size have a very large impact on the size of my interval, the amount of error that's created? So I can use sample size to control the size of that margin of error. I can control the size of the error that my sample can create, okay? And so again, this is something you would do before you ever took your sample in setting up, hey, this is what I'm willing to accept. I need to figure out how big of a sample I need to use to get that result, okay? So let's say the Gallup poll thought the margin of error was too big, okay? So let's say they decided to take a new sample. And let's say they wanted that sample to only have a 1.5% margin of error, okay? And they want to predetermine, well, how big of a sample do we need to make that happen, okay? So margin of error, isn't that controlled by that Z, that critical value we search for, and the standard deviation? These two things together are what create my margin of error, okay? That's part of the formula where we take our sample, plus or minus. Well, that's what we end up plussing and minusing. That's the margin of error. And so we can use this to determine our sample size that we need. So this is the sample size that I'm shooting for, okay? 0.015. That's a margin of error I'm willing to accept. If I'm doing a 90% confidence interval again, didn't we just figure this value out for the problem already? Wasn't this the 1.645? Now, this we're going to talk about two different ways, okay? From their first sample, we have a relatively good estimate what this would be. What did our first sample estimate this to be? 0.25, right? Wasn't that what our first sample gave us, that 0.25? So if you have a good estimate for that proportion, you are free to use it, okay? So our first sample told us that this is approximately 0.25. We are free to use that value, okay? And what we don't know is, aren't we trying to do all of this to determine the sample size? Isn't that the point of all of this, right? So for those of you that like algebra, now you just have an equation to solve, right? So let's talk about how to solve this equation. in a way that keeps it as exact as possible, because you're going to get some really, really small decimals along the way. So I'm going to show you best practice how to get an exact answer with a calculator. Even with these overwhelmingly small decimals, you end up getting along the way. Okay, so before I move over the slide, what would the first thing be that we need to do? If we're trying to solve for n, looking at this, what's my first step? When I divide this over to the other side, it's the only thing outside the root, so it's the only thing I can deal with right now, right? So, first step is I'm going to divide that, okay? I'm going to take the 0.015 divided by the 1.645, okay? And right now, this equals this, okay? Do we agree this is where we're at with our equation so far, right? What's my next step? Square it, yeah. Can't I use a square to undo that square root at this point? This is where you start getting some unfortunate numbers. Because look what happens when I square it. Yeah. So now I have this equaling 0.25 times 0.75 over n. Now, again, this is where I want to show you how to do this on the calculator best to keep exact answers, all right? Now, we've talked about before, I know this has popped up before in class, does our variable do us any good in the denominator? No, so realistically, one of the next thing we would do is multiply this n up here with this nasty, really, really small decimal. And then how would I get the n by itself now? If I have n over here, what do I do with this number to get it now away from n? I would divide by that. So ultimately, can you see my answer is going to be this divided by this? Okay, is everybody following that? Yeah? Okay. Now let me show you how to do that, okay? So how to do that is I have that 0.25 times the 0.75, and I want to divide it by this whole mess, but because it's so small, every decimal spot really has an impact on my answer. Okay, so instead of trying to just type in as many decimals as I can, what I'm going to do is I'm going to divide by that exact answer. All right, this is going to keep it as exact as possible every step of the way to get to your answer. All right, now, can you survey 0.02 of a person? No, yeah.
So I just divided it by that, and I used parentheses even around the squared, and it gave me that. I don't know what I did wrong. Do you divide this first and then square it?
Oh, 0.27 or 0.25.
Dang it.
But yes, that would work. All right. Shh. Now, can we sample 0.02 of a person? No. Now, shh. The thing about rounding in this case, when it comes to sample size, you actually always round up no matter what. So the math in you tells you would round that to 2,255, right? But because this is a sample size, to guarantee the margin of error that we're looking for, actually no matter what, you end up rounding up. Okay? There's no such thing as rounding down in this case. So again, I don't think this is a challenging skill. I just think it's something to remember, and especially knowing the calculator technique to keep an exact answer along the way. That's kind of where it gets a little bit sticky, okay? Otherwise, I don't think the algebra is that bad. I think you can see how this unfolds. Now, the other way that this can pop up, okay? The other way this pops up is, remember I said that you often would do this before you take a sample, right? Well, if you haven't done a sample yet, do you have a good approximation of what your sample is going to give you? No, you don't. So, in order to guarantee a margin of error, you would have to reproduce the worst case scenario, right? Well, what did we say is the worst case scenario? What proportion would give us the largest possible standard deviation? 0.5. So if I'm trying to guarantee I have a margin of error that I'm looking for. I need to provide myself with a worst case scenario. And we mentioned before that zero point 0.5 creates the biggest standard deviation possible, which would be the worst case scenario. So if you have nothing else to go on, okay, no previous information about the sample you're trying to conduct, use zero point 0.5. When you're setting up that standard deviation, okay? Because then you know whatever happens is going to be better than what you just found. All right, so let me show you how that works. So many television viewers express doubts about the validity of certain commercials. In an attempt to answer their critics, Timex Group USA wishes to estimate the proportion of consumers who believe that what is shown on Timex television commercials. Let P be the proportionate or be the true proportion of consumers who believe what is shown in Timex commercials. What is the smallest number of consumers that Timex can survey to guarantee a margin of error of 0.05? Or less, sorry, that should be an or. At a 99% confidence interval. All right. So again, we're going to use that same setup, that same structure. So here's the margin of error that we're shooting for. All right. 0.05. That's the error we're willing to accept. And now we need to construct the margin of error for the interval that we would therefore be creating. Well, remember up here I showed you, this is how we construct that, okay? Now this time, they want a 99% confidence interval, so don't we need to go back and figure out what number goes with 99%? So if I look at my table, 99% gives me 2.576. And now standard deviation, okay? And this is where I needed to clarify about that 0.5, because notice we have no prior knowledge to go on, no estimate that we can assume is going to be true for the sample. So because of that, we create that worst case scenario. So no matter what happens, it's going to be better than this. And the worst case scenario we've talked about is 50-50. Okay, that's going to create the biggest standard deviation possible. Once you set this up, now we're just walking through the calculator technique to get you to the answer. All right, so once again, let's talk about the calculator technique, how I can follow this along to keep an exact answer. What's my first step going to be? Yeah, divide by that 2.576. That's the only thing outside the root. So right now, that's the only thing I could do. Okay. So I'm going to take that 0.05 and divide it by the 2 point, is it 576? Thank you. So right now, this equals the square root 0.5 times 0.5. I'm just going to call that 0.25 to save myself some writing. Okay, I think we all know where that came from. What would I do now? Square, beautiful. So I'm going to square this. And again, this is where now we begin getting those unfortunately small numbers. Okay, so right now what I've got is this monstrosity equaling that. Right, isn't that where we're at in this process right now? And again, remember, we also talked about that n doesn't help us at all when it's in the denominator. So because of that, if I multiply this up, now what do I do with this number that's already here? Multiply the n up, what do I do with this? Divide by it. So I'm going to take the 0.25, and ultimately I need to divide by this answer that I already have. Okay? And again, this is how to keep an exact answer. Okay? So we're getting, and what way do we always round? Always up. So wouldn't this round to 664, right? Now, I've seen the AP exam do this both ways, okay? Sometimes they will literally be looking for that number right there, okay? Sometimes they will have the exact to the units place what they're looking for. That's why exactness and precision are important here and keeping exact numbers. But other times, I've also seen them do this, okay? Where they just list here, aren't they just counting by 50s? And they're like, all right, which one would do it? So I got 664. What answer would that translate to for them? 700, because didn't we say you have to round up? So again, don't panic if you don't find exactly what you're looking for in their answer. Sometimes they do just like count by 50s or count by 10s. So like, all right, find which one you would have to use. Also, sometimes they would actually want the 664. Okay, so just a heads up, I've seen it both ways when they put this as a multiple choice question. All right, let's review one more time how this first step process looks. And then I have one itty bitty skill to show you, and then we will call it a day. Okay? So, a random sample of students who took the SAT college entrance examination twice found that 427 of the respondents had paid for coaching courses, and the remaining 2,733 had not. Construct a 99% confidence interval for the proportion of coaching among students who retake the AP, or not the AP, sorry, the SAT. This prompt right here, remember, that prompt is what tells you to put all of this in motion, right? The 4-step process. So, state step, what do we do in the state step? The only thing we do in it? Guys, what goes in our state step? Yeah, isn't this where we just honestly name it? We tell the AP grader what process we're using. Well, no, because now this is like what the AP exam would be asking for. There's just way too many standardized tests, guys. We just have to do away with all of them but AP stats. All right, plan step. What do we do in the plan step? Yeah, we check our conditions, right? We check to make sure that our 3 conditions are met. The first one is by far the easiest, because isn't the first one just making sure that they told us it was random? Did they tell us it was random? Yes, they did. They took a random sample of students. What about normal? What does that look like again for our proportions? How do we check for? Yeah, oh, what's greater than 10? Successes and failures. Here we go. So we check our successes and failures are both at least 10. Here, they say this is the people who did get training or coaching. Here's the people that didn't. So already, aren't those the successes and the failures laid out for us? What does that mean for our total sample size, though? What do we do with those to find the actual sample size? We add them. So here our sample was actually 3,160. Independence. How do we check for independence? Oh. Yeah, if it's less than 10% of the population. Is it reasonable to think that when the SAT is provided, that this is less than 10% of the students that are taking it at any given point in the US? Yeah, I think so. All right, now in terms of actually setting up this interval, well, the beginning of the interval, don't we just need to know what our sample proportion was? Well, aren't we saying 427 out of 3,160 people received the secondary training or the coaching, right? So we're saying according to our sample, 14% of people taking it twice received coaching for that second time. Again, all I did was 427 divided by the 3,160. Okay? And then don't we build that margin of error? And haven't we've been getting good practice of what that margin of error looks like? Isn't that the number from here and then the standard deviation, right? In this case, 99% goes with 2.576. Standard deviation, well, again, if you ever forget how to do that, remember, this has a little reminder for you, okay? Take your sample proportion, so 14, its opposite, which would be 86. Sample size 3,160. And then again, the bright side of all of this is you don't have to actually do this, right? The calculator command will do this for you. So we go back into the calculator command. Stat over to test. Let me get rid of this. Then remember, in this section, we're exclusively using A. Eventually, we'll get to the point that I'll share with you the strategies to know how to tell which is which, all right? Was it 427? Yeah. 3,160 and 99, right? All right. So the interval is 0.119 to 0.151. And then what does that interpretation look like? When I'm writing my conclusion, what does that sound like? Plagiarize. I mean, basically. Yeah. Isn't it literally always that same setup? And then again, you always take their own language from their prompt. So we're 99% confident the interval from this to this, and then captures the now plagiarize, right? Just take word for word what they said, give it back to them, because then you know that you're using good phrasing. You know you have the context exactly the way that they want it. Just please never, ever, ever tell that to Brooks. Usually, we're paraphrasing, right? All right, one last skill, okay? It's literally only popped up once in the history of the AP exam, but I feel like then it's my obligation to show you how to do it, make sure you're comfortable with it. So the big picture of today was reflecting on the first step process, knowing how to do that, and then how to use sample size to control margin of error, okay? Again, one time I've seen them do this, where they reconstruct, they get a different interval, and then they decide to ask you, well, what level did we use? What confidence level did we use to make this interval? Okay? It's actually a very similar process to what I taught you, just minor difference, okay? So we can use that same construction, the same idea of margin of error. We can use that to go backwards and determine what level was used to create the sample. Okay? Now, let's talk about what that looks like. Okay? So if we're using that same formula, if we're using margin of error, first question for you, if I'm looking at this, how do I determine the margin of error of this? Actually, I wouldn't add this time. Wouldn't margin of error be half of the distance between these two numbers? Yeah. So margin of error, again, yeah, isn't that half of the length of the interval? So if I want the margin of error, at this point, what I'm going to do, I'm going to subtract the 0.14705 minus 0.12321, and I'm going to divide that in half. So the margin of error in this case, this has that margin of error when they redid their sample. Okay. Now, it does say that they used our very same data to do this. Okay. So we know we're dealing with the same sample proportion, same sample size, all that jazz. They just decided to use a different confidence level for some reason. Okay. So again, we're talking about using the margin of error. Okay. We're going to use a margin of error to decide this. Well, margin of error, isn't that made by using that number in here? Now, can I find a number in here? Do I know which number to use? No, why not? Because I don't know the level. That's the key to this. Is if I can figure out what that number is, can't I go back and figure out what level was used to create this? Right? So the goal this time is I want to know what is that number. Okay? That's my goal because once I know that, I can use this to tell me what level made this interval. Okay? Again, we're using the same data, so we know we're using that 14 sample statistic of 14 is opposite, which is this. We know the sample size was this. So realistically, our goal is to get this value right here. Well, that's actually just one calculation away. What's the only thing I have to do to get this number by itself? Yeah, don't I just have to divide by this monstrosity? And that'll get it for me, right? So it sounds nasty, but actually it's easier than the other thing we were just doing because you just have to divide once and you're good. So 0.011, was it 0.00? Was it that? Yes. All right. Divide by square root 0.14 times 0.86 divided by 3,610. Boom. All right. So this is that z. Okay? And again, the cool thing is, if I know what z was used, can't I go back and figure out what level was used? Right? Now, it's not going to be perfect. Okay? I'll tell you that. This is not going to be perfect. But we can figure out which one that's the closest to. So, 2.064. Wouldn't that be the closest to this 2.054? Isn't that the closest thing in this table? So what would the closest confidence level be that was used? 96. All right. That's why you want to try to be as exact as possible. Did you leave extra decimals than what I did?
No, I did 0.1.
Oh, look at you.
So technically I was more.
You were. You're right. All right. All right. And then I think, is that it? Is that the end of the notes for today? Beautiful. Why? Yes. Yes, I do. All right. All right. What we did, I mean, dividing it in 8.2, because with 8.1 is like learning all the terminology without any math. I don't think it makes sense without the math. So that's why I skipped 8.1. All the same numbers. Jake, do you want one? Jake, do you want to learn AP Stats this semester? Do you want to learn AP Stats this semester? Oh. All right. So, guys, the other thing you're getting to remember, this is what's due on test day. So this isn't homework yet, unless you feel like picking up. But yeah, so this is that packet that's always due on test day itself. Yeah. No, because I don't want to forget to get it for you. Should I keep it? Okay. Oh, sure we got it. Dylan. So, that's the game I was sitting with or thinking like have a So like I thought I remember and then I looked away talking about it and the game was over. Darn it, I didn't see it. Well, unless you're super comfortable. Maybe there's like one above you. Like saw it 12. Love it. Is it raining tonight? Yeah. Welcome to AP Stat. I love them. No, it's a really fun crew. You can tell that they're energized.
Yeah.
You can also tell there's very distinct clumps in my room. Like there's the athletic boys, then there's the girls who have always been accelerated in math, and then there's band.
And then there's the band.
Like, and it's funny because they do really clump. Like it's so funny.
That's how it is in every class. They just clump together. You have a band-aid, Posh.
I do.
You're always prepared, I knew it.
I am always prepared.
About to go to Gov now.
Have fun.
Oh, I'm so excited.
It sounds exciting.
So excited to have you for a teacher, because now if I get stuck in college algebra, you could help me.
Yeah.
See you later.